Hello everyone, it's good to see you all here again. Welcome to Autodidact channel. This channel aims to create videos to gain more access on tech related information and the best practices of coding skills. In today's video, we are going to discuss on trait in Rust programming language by practicing and implementing the basic example of trait in Rust programming language. Hope you will learn something new. Let's start into the video. I hope you have already familiar with how to install the Rust programming language. If you are not aware, please check out the previous video so that you will learn how to install the Rust in your operating system. Let's create a Rust file, and for that we need to type cargo new trait example. Once we hit on this file, you could able to see the folder structure which is created by the cargo package manager. In this folder we could able to see the files which is the main.rs file, in which we are going to write our Rust program in order to run the trait function. For now you can ignore the cargo.tom file and git ignore file also. Like if you click on cargo.toml file, you could see the names, like the what is the package name, and which is the trait underscore example, and the version and edition, and all the other dependencies which are included in this package are have been listed in below the this 8 after the 8th line. Let's get into the code. Here this is the main.rs file. In this file you can able to see the main function which is already there, and the print ln and the exclamatory mark which represents the macro and the hello world. So let's try to run this program and let's see how it is going to run. In order to execute this main.rs file, first we need to navigate to the respective folder, which is trait.example. Once we enter into that folder, we can type cargo run in order to run the main.rs file. Once we type the cargo space run, it could build, compile and finish running. Here you could able to see the hello world in Rust. This is how the basic example of how to create a package using the cargo, and how to run the main.rs file using the cargo package manager. In order to create a trait in Rust programming language, we need to define the trait by using this syntax: pub, which is a public with trait keyword and the trait name. Here we are considering the drawable. After that, opening the curly braces. Now we are going to create an method signature inside the trait, which is the drawable trait function. After that, we need to declare, like before we need to give the pub, which is the public keyword, and the fn represents the function, and we are mentioning the draw function, which could takes the self parameter and returns a string. This is how the function signature is going to implement in the drawable trait. Let's create a structure. So here we are going to create a structure which is of a rectangle, square and circle, and we are able to use, by using the draw function, we are going to implement on this structure. Let's see how to implement this structure. Rectangle, and we are going to give two fields which are I32 and width, which is also of I32 size. Same, we are going to create one more struct which is circle, and in this circle we are only having the radius For now I'm taking the float value, which is f32 value. Let's we will implement the drawable on the respective structure. In order to use the trait, we have the keyword like impl, which represents the implementation, and we need to call the trait name, which is drawable for rectangle. So once after, we need to give the definition and the functionality of the signature which is present in the drawable trait. So let's define draw, and which takes self and which could return the string type. Here we are going to return a string of having radius. Let's call this one I am rectangle with length equals to the, the passed value of the rectangle length, and width and the total area. Let's call this self dot length comma self dot width and self dot length into self dot width. This is the string which is going to return from this draw function and which is implemented on the rectangle structure. Let's define the same implementation on the circle, and we are going to call the circle on the drawable, and by making slight change in the return functionality. So it usually have the radius. We are calling self dot radius and pi. Let's area of the square is the pi r square. So in order to import the pi, we need to import the constant of the pi. This is how we could able to call the pi constants, which is of f32 bit. So this is an floating integer, a floating type of data type which is of pi, and we could able to call self dot pi r square radius self dot radius. Yes, we have implemented the trait on the circle and the rectangle structure. Let's define how to call the rectangle under the circle. Let who am 1. We are calling this instance, creating an instance of the rectangle having length of 5 and width of 10. Let's print. We could able to call the draw function. So let's save and run the file. What we have done so far is we have created a drawable trait, and we have created a signature of it, which is of draw function signature, and we are going to use that function as a shareable behavior both on the rectangle and circle structure. And for that, we need to, before using of the function, we need to implement the trait on both the types. So we have created implementation of the drawable on the rectangle, and we have implemented the draw function on both of the types. Now we are going to create an instance which is whoam1 with rectangle structure type. So once we could able to print this, we can able to call the draw function using the whoam1 instance. Let's see here, unnecessary visibility is there like pub, which is not permitted. So we could just remove, save and run the file. save it. Here we could able to see we have successfully called the draw function on the rectangle instance. So let's for one more instance we could able to call the same function using the circle structure. Okay, let's create one more instance which is who I am to, and we calling the on the circle structure. So let's define radius having 9.0. Why I am taking the 9.0, it is due to like it is an f32 value, so it is a float value. So if the Rust which is followed is a very strict programming language, it is strongly typed. If we if we give any like it follows the very strict rules. If we give the only 9, it couldn't able to represent it, it is a float, so we have given 9.0 for it. For understanding purpose, I have been creating one more print line so that it could be visually represent. Let's remove, and we are calling one more draw which is on the second instance. Let's save the file and run the file using the command cargo run. Let's give, as I have already told, it is very strictly typed. We need to specify the semicolons at all. So please make sure whatever the like errors which could you have been expecting, that couldn't be happen on the like compile time. So we could, it could be very beneficial to understand these errors at the compile time itself. So this is a very important concept. Like when we are typing, we don't have to do any typos at all. So let's run this file cargo run so that we could able to see the answer, which is I'm a rectangle and which is having length and the width and the total area is 50, and which is on second function which is the shade function which is called on the circle structure with the draw function radius of 9 and the total area is pi r square. Now we could expect this draw function can be called on any structure type on which it has been implemented. I hope you have understood how to create a trait and how to call that trait on the respective structures. Here we have implemented the trait and used the trait on the rectangle and circle structure. So this is how we could able to call a trait function by using the respective types. Let's see how the Rust implements the very strict rules by using this debugging. Okay. I hope you have already understood how to create a trait and what are the method signatures, right? What happens if we not going to implement that method signature, right? Once if we remove the any function, let's see, once we have saved and run the file, we could expect an error which is not all traits items implemented, missing the draw function, because we haven't defined any default implementation on the draw function. We have been implemented the drawable trait on the rectangle. Since we have taken into consider in order to implement the drawable trait, but we haven't given the definition, we haven't give the behavior of the function which is already made as a signature, method signature in the drawable trait. So this error is very clear and concise. Here you could able to get that draw function is not implemented in the rectangle, right? So we need to missing the draw in implementation. So as the previous behavior, once we have the draw function implementation in this drawable trait which is implemented on the rectangle structure, and save the file and rerun the cargo run. We couldn't now we won't have any error because we have defined all the method implementations which is of the trait drawable. Let's create one more structure which is a square, and we will take length is equals to 5. Like in the square all sides are equal, so we have taken one of the side which is of length, and 5 which represents currently we are going to have the I32, which is an integer type. So let's create the implementation. Implement drawable for square, and the function which is going to implement is the draw function, and the first parameter is the self parameter, and this draw function is going to return a string type. So format is a macro which could returns an string type. So in this one we are going to give a text like I am a square, length is equals to, and total area. So self dot length, which is the one of the side of the square, and self dot length into self dot length, which gives the area of the square, which is of a square, which is a side square. So we could expect that it could be a length square. Let's create one more function which is of the default implementation of the function. So we are calling it is a perimeter, which could usually takes the self, which is the first parameter, and which could returns the string. Here we are going to provide a default implementation. So we simply call it as default implementation, so semicolon. Let's save it. So as this was the default implementation, the whatever the drawable function which are already implemented on the rectangle structure. So what happens if we remove this one, the default implementation? Let's remove and save the file and run the file which cargo run. We could see that perimeter is already there. It expects the perimeter implementation. So let's try having the default implementation, and let's save the file and type cargo run. We could see that a default implementation which is having which is of string type. This whatever this error, let me explain. Like as this was the format function, first of all there is a typo, which is a format and format macro, both are different. And if it is an semicolon, it makes it a statement, it's not a return type. So once we remove the semicolon, it could assumes that the statement which returns the string. Okay, like once we save the file, as this was the default implementation, we couldn't get any error at all. Yeah, we haven't get any error. It has been compiled successfully. So let's create perimeter default function which overrides on the rectangle, which is perimeter, which takes a string I am a rectangle, and the length and width having total perimeter of a rectangle is 2 into length into width. So this is the formula of the perimeter of a rectangle. So now we are just discarding the circle one, and we are doing the same thing on the square. So it is of a square and having the length which is already known, and the total perimeter of the square is 4 into length. So we can call it as 4 into self dot length. So once we save the file, and let's call those perimeter function. So for that we already have a circle and a rectangle, but on the circle we haven't defined any of the perimeter implementation, so it could usually call the default implementation. So let's call the same. So now we have the I have added a separator in order to make a visible appearance. So we could call the perimeter function on the rectangle structure and the same perimeter function on the circle one. And let me create a one more thing which is called a square, and I call it as a variable which 3, and the length is, as it was an integer, so we could only pass the integer value, so which is of 6, and we can call the same thing on the perimeter function on the square one. We have created the perimeter function implementation on the rectangle, circle and square. Let's run the function. So let's clear the console and type cargo run. So now we could expect the first section of the, which is a draw function, which is called upon the rectangle and the circle, and the second one is the rectangle as the who I am 2, which is a circle which doesn't have the default which doesn't have the implementation of the perimeter. It calls the default implementation, so we could expect I am a default implementation. And the square which already having the implementation of the perimeter, it calls that perimeter function. This is how we could able to share the behavior of the function by using the traits. In other programming languages we could call it as an interfaces. So same way we are going to create that type of functionality in the Rust programming language. All the method signature must be defined when it is implemented on the particular trait, and the default implementation is not mandatory to implement. It could call the default implementation if there is no implementation on that particular on the particular type. Yeah. If it has only the a single default implementation, then there would be no need of implementing the that particular function of a trait. So this is how the trait concept in the Rust programming language. Hope you have learned. Let's see like what happens if it has multiple traits, and also how to pass the trait as a parameter into a function. Let's start how to implement the trait on the parameters of a function. So for that we need to create a function. In order to have this function publicly, we can add the pub keyword on the public and the return drawable. We could simply call it as return drawable, and it doesn't have any parameters which could implement the drawable, which returns the drawable by using the function. So let's return the structure which is of length having 67 and width having 70. Let's see how it could work. Like here we have defined a function which returns an which could return a type of a structure which is a rectangle, which is a structure type, right? It's an user defined structure. So if we have the semicolon, we already seen that we could get an error as this is considered a statement. So we don't have to put the semicolon, we have to just return this type. Okay, like once we return this type, it could return it will usually implement the drawable trait, right? So once let's try to print the return drawable function. So for that, print macro, println macro. So let's add a separator and println macro. We call it as return function. So the expected is return drawable dot draw function, as this was the we could able to as the already the draw function has been implemented on the rectangle. We could expect this implementation when we call the return drawable dot draw. So let's save the file and run the cargo run. So as this was the public trait, let's debug the error. As this is the function which returns the implementation of the drawable, we will pass the function parenthesis in order to call that function. So this could returns that drawable implementation. After that we are going to call the draw function, right? So once this is the correction, so once we correct this part, and let's try to save and run. So now we could expect the return function, and which is of the rectangle, right? So if the same way if we pass square having the length of 100, we are calling the draw function, and let's run the file. Now we could expect the square as it already has the draw function, right? If we call the parameter, usually if it is having the square has a perimeter implementation, so it could call that function, or else it could call the default implementation of it. Let's run the file. So we could see the length, and the same way how this is how we could return an a drawable implementation also by using the like the how the functions accepts. Previously we have known how it could accept the implementation and how it could returns the drawable trait. Let's see how we can call the drawable trait on the parameter. So we have defined a return drawable 2, and which could implement the yes, we have implemented the drawable on the parameter of the return drawable 2. Let's print this part, and let's see we could able to print the drawable function on it. So item dot draw function. So we need to call this function. For that, the main function, let's make it as a drawable 2 equals to, and let's go to the main function, and we'll call this function which is an drawable 2, and we will pass the let's pass the square. Okay, square structure having length equals to we can say that 500 for now. So now we are passing the square structure, which could usually pass to the parameter of the item, which is a type of having the implement drawable function. So what could expect from this is the string. We can able to, we are not expecting any return type. So let's save it and clear the console and type cargo run. As we have missed the typo of the semicolon. Let's run the file. Yes, we have added a semicolon here also. So let's clear it again. Cargo run. Let's type cargo run. Okay, here this is the return variable 2. It returns nothing, and we are just simply printing the function of the draw function which implements the on the variable. So let's call the same function with the rectangle, a rectangle which having the length and also width also having 400, which are both of integer type, so it's fine. So let's call the cargo run. Now we are expecting the rectangle implemented draw functionality. So this is how the length, width and the total area has been calculated, and this is we have successfully passed the uh, type structure to the item as a parameter, and we are going to call that parameter dot the function name. So this is how we have implemented, and there is one more we could able to for concise. There is a trade bound syntax which has been used. So this is how it has been used. So let's remove this implementation, and we are simply calling the t to the drawable, and we are passing that t to the item. So this is also the same function, which is a simple concise function. This could be helpful when we go into a complex trait functionality. So this, let's run this code. Let's see whether we could get any errors. No, we haven't get any errors. So this is also a successful like syntax in Rust. So we could also use this implementation also. Like this is how we could able to pass one more trait, which is an display, which is present on the which could defaultly given by the Rust. So if we run this, we might expect error. So for that, in order to import the display trait, we need to have this module imported. So let's import this module, save it, and let's rebuild it. We have successfully imported. So this is an usual and so this is how we could able to call two more traits on the respective trait as a parameter. There is a one more syntax which provided by the Rust. So let's see what is the difference between both. And this is the trait bound, and we could call where t equals to drawable. So, and we will define remove the t, and this is how syntax could work. Let's save it and let's comment the above code. Clear cargo run. Yeah, we have successfully called these three syntaxes. I hope this is one of the syntax, and there are three ways which we have used in order to pass the trait to the parameter. Like first one is using the implementation keyword which has been directly appended to the item, and the second case is without the where clause, and the third case is with the where. So let's just recall how we have defined the trait in the rest concept. The first thing is we need to use the trait keyword in order to define a trait which is of the drawable trait, and this is the method signature, and this is the default implementation of the function. And we have the structure type of rectangle, circle, and square. We have implemented the drawable trait on the rectangle and the circle and the square. There is a scenario if it has the default implementation, it is the Rust compiler won't force us to do the implementation of the default implementation provided by the trait. If it doesn't have any default implementation, rather than going straightly, the compiler will force us to give an implementation if it has only the method signature. And the next case is how we can pass pass the structure type to the function, and we can expect the how on the parameter we could able to call the trait functions. Okay, and the one of the scenario is the return drawable to function, and the return drawable which could returns the implementation on the trait. So once the return statement of the return drawable, we could able to call the drawable trait functions on the particular return type which has been returned by the function. I hope you have better understood on how to implement the trait, and how what are the different syntaxes, and how to use the trait functions on the different structure types. And I hope you have learned something. It's good to see you on the next video. If you liked my content and more interested on these videos, please click on subscribe button and hit the bell icon to get notifications on future video posts in this channel. Hope have a great day.